Hi, everyone. So we're going to get to the root of the problem today. All right. So we remember we're in the new Algebra 2 book. I guess new, and hopefully you have the volume 1, not volume 2. Well, you will need volume 2, but just not yet. And if not, then you might have to schedule an appointment at school. Sorry. So here, the warm up today. Remember, it's just distributing the answers if you want to take a look at them, and right here. So make sure you do them if you did not do them already. These are the answers. Let me just, yep, and this one right here. Okay, so that's what, those are the answers. Remember, you were just distributing those. If you want to use the box method, you could totally do that as well. Today, your learning goals are going to be to factor quadratic trinomials y so that we can find the roots, right? And because, when it's in factor form, that tells us what the roots are. And then the quadratic formula, when we can't factor, then we use quadratic formula. There's completing the square way, but that is not so useful. So these are the two main ways that people use to solve for x. Okay, and other than the normal way that we know. So if you look down here for the next, not down here, but on the next page, if you see just one x, okay, because the above two that I just talked about, those are if you see like x is in two different places and you can't really solve x in any traditional way, right? So if you just see an x like this, you just solve it like the way you would normally solve it in Algebra 1, right? You just have the added like square root there. But remember geometry does that already. So again, so when it says use properties of equality, right, to solve each equation, what it means is just solve for x, right? So the property of equality just means that, oh, we're adding, like, let's say here for a 9 on both sides. Is that the property of equality of addition, which says that you can add the same number on both sides of the equation and it'll still be equal, right? So here we have, so we got to get rid of that -9 because we want to get x by itself. That's the whole goal of this. And we get x squared is equal to 36. And remember, when you square root it, right, that's the inverse of a square. That's just going to be 6, but not just 6. It's going to be 6 or -6, right? It's got to be both, right? Because both are answers. It could be 6 times 6, which is 36, or -6 times -6, which is also 36, right? We got both. So normally when you guys, again, when you guys were in geometry, you didn't worry about the negative because you're never going to have a -6 inches. Like, what is that? Right? How long is that? It's like going back. You can't do that. All right. But in algebra, we can have a -6. It is possible. So that's why for us, we make that distinction. We need to state that. Again, if you look at B, it's kind of like A, but not really like A because you notice that there's a parentheses with a square on the outside, which means we got to get rid of that first. Okay, so we're going to square root both sides first. And now we're going to, when we square root both sides, remember, we got to add in the plus or minus right here, 11. And then we're going to subtract 3 on both sides. So we're going to get something that looks like this. So x is equal to -3 plus or minus 11. And we always, standard form, we always put the plus or minus at the end. Okay, now we're going to actually simplify this because we can. So -3 plus 11 is 8. -3 minus 11, that's -14. So again, remember, like I said, we have 2 answers. So whenever you see a square, you're going to expect 2 answers. Okay, that's the normal expectation. And then for C, well, it's kind of close to B, except we have this number outside for here, right? So what we're going to do is we're going to get rid of that. Okay, it's like reverse order of operations. So in order to get rid of that 3, since it's multiplying with the parentheses, we got to divide it out. So that's going to be divided by 3. 40 divided by 3 is 16. And all we have left now is the x minus 1 squared. So now we're just back to where we were at B, square root both sides, and then they add 1, right? And then we get 1 plus or minus 4, which is going to be 5 and -3, because 1 plus 4, 5. 1 minus 4, -3. Get in the habit of writing that down. Now, D. That has a lot of things going on, but treated exactly the same way. So again, we're going to get rid of this minus 18. So this is going to be plus 18 on both sides. Then how do you get rid of this 1/2? It's still multiplying, right? So you're just going to multiply by the reciprocal, which is 2. If this is 1/2, then this is 2/1. So you're multiplying by the reciprocal to get rid of that fraction, or just the whole number in general. And all we have left is the x plus 5 squared and 18 plus 2, or 18 times 2, which is 36. And now we're going to square root both sides. And so square root of 36 is plus or minus 6. And all we have left is this plus x plus 5. And then we're going to subtract 5 on both sides to get x is equal to negative 5 plus or minus 6. What does that mean? It means negative 5 plus 6, which is positive 1. Negative 5 minus 6, which is negative 11. Right? Those are our two answers. And if you remember, we talked about Oscar. And if you take a look at Oscar, this is the original, right? And we did this already technically with A right here, right? We said it was plus or minus 6. And he looks like he's doing a little bit different. So what he did instead was he subtracted 27 on both sides, right? We had added 9 on both sides to get x by itself, but he's like, well, let me see if I could factor this. And so he simplified that and got x squared minus 36. And that is actually what we call difference of squares, right? Because we're subtracting, that's the difference. And then x squared and 36 are both perfect squares, right? So that's why they're called difference of squares or difference of perfect squares. Either way, same thing. And then, so now that since it's equal to 0, it's going to be 0, x minus 6, x plus 6, right? Because remember that middle term will cancel out because they're both exactly the same, except one is a plus and one is a minus. Yeah, so the middle terms cancel out, just like how it is right here. And then we're going to set both of those two terms equal to 0. How can we do that? It's the zero product property, which means, what in the world does that mean? That means that if we're multiplying two numbers together and it equals 0, then we could get an answer two different ways. If the first term is equal to 0, or if the second term is equal to 0. Like term, when I say term factor, second factor is equal to 0, I should say, right? So here, so either if this is 0, right, this x minus 6, if that's equal to 0, then this whole thing is going to be equal to 0, which is an answer. And if the right-hand side, if x plus 6 is equal to 0, that will also work as well. So we have two different ways for this to work. So so we're doing both ways. Let's see what are all the possible ways. So x minus 6 equals 0, solve it. Pretty simple, right? You don't technically need the parentheses there, just saying. And then so we get the answer of 6 and negative 6, just like how we did right here. I just think this is a little bit easier. That's just me though. But if you want to do it that way, be my guest. I will not stop you. All right, so again, we're gonna do solving quadratic equations by factoring. So this was again another way to do it. So this is when, like, there's two different x's. There's an x squared here and a regular x here. Like, whoa, you can't get x by itself. It's not possible. This is when you're gonna do factored, either try and factor it or use a quadratic formula. That's when this happens. Okay, you can do it for these. You can totally try and factor them or try and use a quadratic formula. You can't get an answer. Just why do that when you have a much shorter way of doing it, right? So it's good for you to recognize or to be able to recognize when you do what. All right. Always saying, is there a faster way, a faster but legal way? Okay, we're not going to be like, oh, we'll just look at the answers at the back of the book. Okay, I don't think there's answers at the back of the book, but just make sure that this is 0. So do you see how it's x squared minus 4x is equal to negative 3? We can't do anything unless it's equal to 0. Okay, we can't use a quadratic formula unless it's equal to 0. We cannot factor unless it's equal to 0. Either way, has to equal 0. Okay, so this is a big no-no. We're like, oh, gotta move that. So this is why they added 3 on both sides to make this negative 3 become a 0. Okay, if you just erase it and make it into a 0, that's not the same thing. That's an illegal move. All right, so that's what we have here. So now we have this trinomial here and it's equal to 0. Yay, this is when we know, okay, we could either factor it or we can use a quadratic formula. It does not matter which one, but I would say factoring is a lot simpler, okay, and a lot less likely to make errors. All righty, and since it said, the title said solve quadratic equations by factoring, this is factorable. Yay. And if you guys remember, what two terms multiply to x squared? Like, oh, x times x. And what two numbers multiply to 3? 1 and 3, right? The negatives I put in there later, but x times 1 is going to be x times 3 is going to be 3x. But note, this has to add up to a negative 4, which means both of these guys have to be negative. Okay, just remember when you do that, you got to include that over here. So that's negative 1 and negative 3 technically, right? And just as a quick check, negative 1 times negative 3 is positive 3. So we're good to go. Now we're going to write it as a factor. So this is going to be as a x minus 1. Here's x minus 1. And here is x minus 3. There's x minus 3. Going straight across the way. All right. And just like the zero product property, we can just set both terms equal to 0. So x minus 1 equals to 0, x minus 3 equals to 0. Honestly, if you can do the math in your head, that's fine. If you set them up like this and you just go, okay, well, that's going to be 1 and that's going to be 3, I'm fine with that. That's okay. But if you're like, oh, I really like it, I really like to write it down like this, then write it down like this. That's fine too. Okay, so x plus 3, like that. So x equal to 3 here and x equal to 1. I just like you to combine it into one solution. So x equal to 1 comma 3. No parentheses. If you put a parenthesis in there, that's completely wrong. You just gave me a point. And this is, I talking about two different values. Okay, we don't want that. All right, and it says, remember, what is the connection between the worked example and determining the roots from a factored form, right? So if this is exactly finding the roots are, basically this would be for if f of x is equal to x squared minus 4x plus 3, this guy right here, right? That's all related, right? And the x minus 3 times x minus 1, that is factored form of that. It's the exact same equation. This is in standard form, this is in factored form. All right. And some of you guys may have been like, well, your x minus 1 is, does that order matter? And no, it doesn't matter. Remember, it's multiplying, so order does not matter. All right. So for number 2, we had decided, okay, what is, because they both got a thumbs down. What's wrong, right? Angela didn't set it equal to 0. Dwight also didn't set it equal to 0. So cannot use those things. Those are not a thing. You can't do that. This is not the 7 product property. There's no such rule. Okay, it's only for 0, right? So if you take a look at this, your answers, then you are going to be factoring, and you are going to and then set it equal to 0, and you should get the answers of 1 and -3, -7. Follow the work. Okay, and same thing with Dwight. The only thing with this one is it's a little bit different. Dwight should have used Angela's technique. Remember, always the first step is that people forget is GCF. Is there a GCF? And these are only 2 terms. So yeah, there's a GCF. It's just x. So we're going to factor out the x. And then what do we have left? X plus 5. That's it. And so in previous times when we did this, we remember we just divided out the x like this. And so what do we have left? So we're just going to have x plus 5 equal to 0. Okay, and then we just go on and do x is equal to 0, x is equal, or x plus 5 is equal to 0. X equals to 0 is already done for you, so you technically don't need to do anything. So 0 is an answer. All right. Now, if you take a look at these ones, factoring wise, this kind of looks like what Dwight was doing, right? But the only thing is that there's this big old fraction, kind of scary looking. So what we're going to do is we're going to get rid of that fraction. How do we do that? So how I like to do all of them, it just requires so much less work, is basically you're going to multiply by the LCM, the least common multiple. So basically you think to yourself, what number does 3 and 6, because the denominators are both 3 and 6, do 3 and 6 both go into, right? You're like, 18. But like, let's see if there's a smaller number. And some of you guys may have thought of 12. And you could do 12, you could do 18, but the smaller it is, the less complicated it's going to be. So 6, right? Because 3 goes into 6, 6 obviously goes into 6. Okay, so what I like to do is I like to divide first, because that makes the number smaller. And then I multiply it. Okay, so I go, watch carefully. So I'm going to take 6, divide that by 3, which is 2. And 2 times 2, which is 4. There's my 4 right there. Okay, I'm going to do the same thing here. So 6 divided by 6 is 1. 1 times 5 is 5. Okay? If you want to, you can just multiply across. So we go 6 times 2 is 12. But do you see how we get bigger numbers? And I don't really like that. So, and then 12 divided by 3, still 4. 6 times 5, which is 30. 30 divided by 6, still 5, right? Do you see how we get the same numbers, but you just had to deal with bigger numbers? What if this was like a 12, then 6 times 12? You really want to do that? I mean, if you want to, right? But I'd rather not. That's why I like to divide first. And now magically, what? Or should I say mathematically, we have no more fractions, right? And if you notice right here, we're just doing just like what Dwight did right up here, right? Which is just factor out the GCF. So an x is common for both of them. And what we have left is the 4x minus 5. Again, set those two apart, solve. Okay, and you should get 0 and 5/4. Again, if you are not working on these by your hand and trying to do it yourself, I do that. I like pause, try it yourself, okay? Because I know how to do it, but do you know how to do it? And you got to give your brain a chance. And here, over here on the right-hand side out, the question was just, well, what if we used 12? What if we didn't get 6? We got 12 and we couldn't think of 6. Does that work? Yeah, it still works, right? It's just bigger numbers, but it totally still works. You can take a look at it over there. And this one, I just didn't do the work for this one, but this one would have been 4x minus 5 is equal to 0. So it's still going to be 5/4. So it's going to be comma 5/4. Same answers. All right, moving on. Going. Okay, we're not doing completing the square this time around. We are going to go over the quadratic formula. And here again, quadratic formula as a reminder, right here. Although all of you guys should have written it down somewhere. I don't know where, like on a sticky note, put it right on your computer. All right, so we're going to go and do number 4. This is on page 86. And always the first things, so if I see a decimal here, I'm like, okay, this is probably not factorable, not going to try. So we're going to just go straight to quadratic formula. All right, and we're going to take a look at this. And remember, we needed to find our A, B's, and C's. Oh, I'm going a little bit too high. Our A, B's, and C's. Oh my goodness, nobody called me. This is bad. Nobody said anything. So bad. All right. Do you see the mistake? Okay, so 2, good. B, yep, 10, good. C, that's a negative. Nobody said anything. You guys just let me do that. That's messed up. I just found that out right now. Very moment. You're seeing it. Okay, so that should have been a negative. Ooh, that's going to change my answer. Where's my, see, now I'm going to have to figure this out by myself. Oh, sad days. Okay. So now, inside the, remember the discriminant is the stuff inside the square root. So I got 100 minus 4 times 2 times negative 1.02. Okay, I got 108.16. Peoples. I'm a little bit disappointed, guys. Okay, so I'm going to go 108.16. So let's see how much that changes. Ah, this would have been a lot better, but oh well. So now, this is the bad days one. So people who aren't watching the video are not going to know this. So this is going to be negative 10 plus or minus 10.4 divided by 4. All right, so that's going to be negative 10. So negative 10 plus 10.4 is going 0.4. You should know this. But 0.4 divided by 4 is going to be 0.1. I use a calculator for that. This is what happens sometimes. You just get in a roll, right? So negative 10 minus 10.4 is going to be negative 20.4. Divide that by 4, and that's going to be negative 5.1. Happy days, yay. Do we need a round? No, because that's exactly in the 10th place. We had a good discussion about significant digits, I suppose. Again, but nobody stopped me. Sad days. This is what happens when people are sleeping. Maybe I was sleeping. All right, moving on. Actually, if you guys want to try this one, B, try B. Let's do it right this time. So our A is going to be, so do it, pause it. Do it first. Oh, and then we got C is equal to, I'm not going to forget this time, negative 2. No es bueno. So x equals negative 11 plus or minus square root b squared, 11 squared, which is 121. This is what I like to do. Minus 4 times a times c all over 2 times a. You got to say and write differently. All right, so negative 11 plus or minus square root. This is going to be 12, 24. 121 minus 24. 97. Oh, it's not minus though, it's plus. Ooh, 121 plus 24. Yep, 145. Okay, 145. And this is over 6. I'm not even going to try and see if we can simplify this radical because it says round to nearest hundredths, right? So literally in my calculator, I'm going to put square root of 145, which is going to be 12.04. Yeah, well, I like to be a little bit more exact. So I just round it at the very, very end. If I round it now, it might be too much. 04159. Well, yeah, that should be good enough. Over 6. And then we're going to go negative 11 plus square root. Actually, I don't even need to write that down. Oh well, because I'm just going to use the square root of 145. It's not that hard to write. So I got x is equal to 0.17. And then we're going to do negative 11 minus square root of 145, which is going to be, and then push enter, and then divide by 6. And that's going to be negative 3.84. Oh, exactly like that. Not a lot of rounding to do. It wasn't exactly that, but all right. They all rounded. They stayed at 84 and 17. All right. So those are your answers. And that what should have been. Because I'm pretty sure I got all the negatives. Oh my dear, now you make me second guess everything. So now this is the part where you can fast forward it, go to the end, okay? But if you're curious, because this will help you in your pre-cal times, if you would just want to see, okay, and maybe you can try it out. So if you have these two quadratic equations, right? And I know this one's going to be open up and this one's open down, so it's probably going to look something like this, where we're going to have those two intersections, right? We got to figure out where. So this is what we do. So we're going to just say, well, we know that these are, so it says set the expressions equal to each other. So you're going to be like, well, they're both equal to y, which means this x squared plus 3x minus 5 is equal to what? Negative x squared plus 10x minus 1. Okay, so we did that, and then it says solve the resulting equation for x. So I'm going to put everything to the left, okay, because I see this negative x squared here. So basically what I would do, I'm going to just do it all at once. So I'm going to go add x squared. I'm going to subtract 10x. I'm going to add 1. And on the right-hand side, all of these cancel out, become 0, which is what we wanted, right? So 0 is equal to x squared plus x squared is 2x squared. 3x minus 10x is going to be minus 7x. And minus 5x plus 1 is going to be minus 4. Okay, so we have that so far. And as we didn't solve for x yet, though. So either we can do factoring or do the quadratic formula. I'm going to try and factor first. Okay, so I know this is going to be 2x and x. Okay, doesn't matter which one's the 2. And then here I'm going to try 2 and 2. But if I do 2 and 2, I'm only going to get even numbers and I can't get it as 7. So let's try 4 and 1. So if I go 4 and 1, 4 times x is going to be 4x. 1 times 2 is going to be 2x. Okay, this is not going to give me a 7. So let me just switch that. So I'm going to go 1 and 4. I think this will work. So x times 1 is 1x. 2x times 4 is 8x. Okay, well, which one has to be negative? It has to be my 8x, which is going to be negative. Okay, so this is going to be my negative 7x, which is exactly what that is. Right, and then negative 4 times 1 is going to be negative 4. So we're good there too. So our factored form is going to be 2x plus 1. Oh, I'm already going into the zero product property there. And x minus 4. So this is in factored form. Now, we're going to remember we're just going to set these equal to 0. So we're going to get, what is it again? We're going to solve for x. So 2x is equal to -1. X is equal to -1/2. And here, plus 4, x is equal to 4. So it's going to be -1/2 and 4. Boom, 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 boom. Right. Oh, we're not done yet. That was the answer for that part. I should have, oh, not yet. So if we know the x, we have to figure out the y because it's a point, right? We want a point. Like that's the whole solution. So calculate the corresponding y values. Honestly, it doesn't matter which one you use because either one is going to give you the same point. So you just look for the easier one. What looks easier? I'm like, oh, the first one looks easier. So I'm going to just use that first equation right there because it should give you the same points, right? So y is equal to, so I'm going to try the -1/2 first. So I'm going to put in -1/2 squared plus 3 times -1/2 minus 5. And you're like, ew, that's why I did this first. It's okay. So negative, oh, honestly, we just put in your calculator. So this is -1/2 is -0.5. So don't forget your parentheses, -0.5 squared plus 3 times -0.5 minus 5, -6.25. So one of our solutions is going to be, I'm just put -0.5 since I'm using decimals right now. So that's going to be our 1 point. Our second point is when x is equal to 4, right? So we're going to plug it in for 4. So y is equal to 4 squared plus 3 times 4 minus 5. Where am I getting this equation? Remember, it's this first equation right here. This guy right here. Okay, you could have used the second equation. Doesn't matter, it'll give you the same answers. So y is equal to, that's going to be 16 plus 12, 20, 16 plus 12 is 28, minus 5 is going to be 23. Okay, I'm going to check that. I have nobody here to stop me. Yes, got 23. All right, so our other point is going to be 4, 23. Those are my 2 points. Okay, those are the 2 solutions that we would have. So that's where the 2 parabolas intersect. Okay. All right. So we would have graphed them on all that kind of stuff, but unfortunately we can't do that. So if you want to try this out, I'll just do it really quick. If that will help you. If not, if you're like, I think I get it, then try it yourself and see if you do. Just go over to the end. Okay, so it's going to be, so it says factoring. So remember, if we're factoring to find the roots, we're going to set this equal to 0. And I noticed that a 2 can be pulled out of all of these guys. So I'm just going to go 2x squared plus 2x minus 3 is equal to 0. See how the factoring is much easier now? So we have x and x. And this can be 1 and 3. Which one of these has to be negative? It's got to be the 1 because it's going to be a negative positive 2, right? So just as a check, x times -1 is going to be negative x. X times 3 is going to be 3x, which is going to give us a 2x. Yay, same thing. And so it's going to be x minus 1, x plus 3 equals to 0. Do not forget the 2 that we factored out there. Well, it's really not going to matter. Okay, and if you remember, we're going to set everything equal to 0. The reason why we don't factor, if we want to get rid of it, we can just divide both sides by 2. It's done, it's out. Okay, and because we know 0 divided by 2 is what? 0. So it doesn't even matter. So unless it has a variable, it doesn't matter. So x minus 1 is equal to 0. X plus 3 equals to 0. So we're going to get the answer of 1 and -3. Just like that. All right. For completing the square, if you remember completing the square, So I'll just do it just as a good review. Remember, we're still setting equal to 0 because, again, we're still finding the roots. Where does it cross the x-axis, right? Here I'm going to just divide out the 2. So divide 2 on both sides. So it's x squared plus 2x minus 3 is equal to 0. And if you remember, we're going to just add 3 to both sides, right? So add 3 to both sides. But you'll see how this is a little bit longer, but although I think it's fun. And leave some space, equals to 3. Now remember, we're going to set up the perfect square. So how do we get this term? Because these two have to be the same. We're going to just divide it by 2. So divide b. So it's going to be 2 divided by 2, which is 1. Then we're going to square up, so it's plus 1, right? So 1 plus x plus 1 squared is the same thing as x squared plus 2x plus 1. Exact same thing. It's just multiplied out all the way on top here. And since I just added this plus 1 on the left-hand side, I got to add 1 to the right-hand side, right? Got to be fair. So this equals 4. So now this looks like the very first things that we did in the beginning, right? And we're going to just, it's like b, remember b? And then we're just going to square root both sides. And you're going to be like, oh, this square and the square root, they cancel out. So x plus 1 is equal to plus or minus 2. You're like, well, subtract 1 on both sides, and we get x is equal to negative 1 plus or minus 2. Well, what's negative 1 plus 2? 1. Negative 1 minus 2, negative 3. Which way was easier? It's up to you. All right, and then we're going to use the quadratic formula. So here, I need the, so 2x squared plus 4x minus 6 is equal to 0. Normally we don't think about GCFs and all that kind of stuff, so we're going to just go straight like this. So a is equal to 2, b is equal to 4, and c is equal to negative 6. Do not forget that negative like I did. Sad days, wrong answers, right? X equals negative b, negative 4, plus or minus square root b squared, 4 squared, which is 16, minus 4ac, which is negative 6, all over 2a, equals negative 4 plus or minus, what is that? 8, 48. We're adding 48 to 16. 16 plus 48. 64. Oh, good. That's a good number, which it should be because these are just whole numbers here, right? Divide that by 4. But do you see how many different places you can go wrong here? I've seen just even one negative that you missed. Like you might have put it here, but forgot to put it here. It's possible, right? So remember, square root of 64 is just 8. So this is just going to be negative 4 plus or minus 8 over 4. So negative 4 plus 8, which is 4, divided by 4, which is 1. And negative, maybe I should. So it's going to be negative 4 divided by 4. And the other one is negative 4 minus 8, which is going to be negative 12 divided by 4. Well, what's negative 4 divided by 4? 1. So x equal to 1. And negative 12 divided by 4, which is 3. I mean negative 3. Did you catch that? You're like, wait a minute. See how all the answers are exactly the same? And with graphing, well, we could do the graphing now. You wouldn't solve it with graphing because, you know, this is what we're trying to get to. So we do know, though, that the roots, we've found the roots 3 different ways, is 1 and negative 3. So here's 1, and here's 1, 2, 3. There's negative 3 right here. So there's the roots. What's the y-intercept? Remember, the y-intercept is this part right here in the standard form. That's the y-intercept. Super easy. So y-intercept is negative 6. So we're going to go 1, 2, 4, 5, 6, about equivalent intervals-ish. That doesn't look like the vertex, right? It's because it looks a little lopsided. So vertex, remember, I wonder if there's an vertex. We know the AOS, right? The AOS is just this part right here, right? Negative b over 2a. This is, oh, let me do it in pink. This is our AOS. So we have it as -1, which makes sense. It's -1 right here like this, which means our vertex is somewhere here. What could it be at -1? Do we have a one that's easier? We almost had the vertex form with this. Oh, right here, vertex form. Technically, if this is like, if you're like, Miss Lee, this is too confusing, don't worry about it. This is a vertex form right here. Except instead of having the 4 over here on the right, we got to bring it to the left. So we got to subtract 4 on both sides. So this is, pretend, if you know, remember we had this as equal to 0, but that was only because we're finding the roots. This is technically y is equal to x plus 1 squared minus 4, right? The vertex is, remember, -1, -4, right? It's opposite of what you see inside the parentheses. So -1, which is what we have, -1, and -4, which is right here. That's -4. Okay, so, oh, something's weird. What did I make a mistake on? -4? I don't know, but you know how I know that's that, because that can't be the vertex, because that means that's the lowest and highest point, but we have that at -6. That doesn't make sense. Oh, because we, remember we divided out the 2? Bad days, Miss Lee. Okay, so it can't be that. This is not possible because we don't have the 2 there. We did all this calculation without 2. That's why it wasn't working. Oops. So, but we do know it's going to be down here. So I'm going to guesstimate. I'm not going to calculate right now. I don't have time for that, but it's going to be probably around like -7. Okay. Oh, that's supposed to go through it, but I didn't. Sorry. But there is that other point right over here. Remember the reflective? But anyways, so yeah, that's what that would look like. Whoa. I was like, wait a minute, what is going on here? All right, but that's how we use your logic, right? If your graph is looking a little strange, granted for this unit, you don't have to write a graph, but next unit we will. I'm just saying, if it looks a little strange, you're like, wait a minute, you got to think about it, okay? That's how we problem solve. All right, homework, practice. See you guys later.